Our next speaker is Gilad. You can go ahead. I'll just put your okay, just a second. Here we go. Yes. So Gilad Goldenberg, he's an algorithm leader in Metronics CTO department. He built from scratch and manages the algorithm and sensing department at Metronics, mechanics, electronics, algorithm, AI, and low-level embedded, solving and designing complex systems, mainly in the robotic field. So thank you very much. Here you go.
So I see you have a timer, so it's running. Okay. So I'm Gilad Goldenberg from Meetronics, here to talk about algorithm sensing and in general consumer robotics, and specifically in pool. How do you say?
Or use those or
in the mouth. Okay.
Yeah.
It's with the okay, a summary of the lecture, a little bit about Meetronics, a little bit about the team mission, an example of features that we did here in Meetronics, and 5 minutes of questions. If I will know what to answer, I will answer. If no, I will make something up. And לא ידעתי שזה עם סליידים כאלה, האמת. Okay, so Meetronics started in 83 in a little kibbutz in Israel, kibbutz Israel. A little bit about the market of pools. So we have about 30 million pools in the world above ground. That is a new concept. It's not really new, but in the coronavirus, it started to be very dominant. So about 10 million pools and to about 20 million pools in-ground pools, and of course about 500,000 million pools of country clubs and hotels, stuff like that. Also, we have robots that aim specifically to this department. A bit statistics, we have about 50% market share in the pool, in the industry of pool robotic cleaners. Okay, it's like not all the cleaning types of pool is robotic cleaners. It's important to say. About 1,700 employees, 65 countries. Like I said, big thing. Product board, we have about 1,500 types of robots, like maybe 20 or 30 platforms, but you know, each country and each supplier needs different types of software, maybe this kind of cycle, maybe 100 minutes, and the Australian needs 200 minutes. Prices levels are about $500 to $2,000 to the private section. Of course, we have also the professional section is much higher prices. So main points, how about him with the time? It's okay. Main points for consumer robotics from my experience. So we have 3 main points: the user experience, price, and robustness. Okay, so user experience, we're talking about effortless consumer and privacy. Okay, effortless, I'm talking about if we want to do like navigation in the pool and make the robot come back to the same edge of the pool every time. So of course you can say, okay, let's make the customer glue some stamps, or maybe install a beacon on the pool, but then it's not effortless and it's much hassle to the client. So it's not, we can't treat it as a solution. Price, we're talking about BOM, takt time, COGS. Okay, we are manufacturing here in Israel, and everything is very important. The takt time, we're measuring the minutes, maybe 1 minute, 2 minutes, 2 minutes in 5 seconds for each robot. Very important for the overall cogs of the robot. And robustness, work well time after time in every environment. That means that if I do, for example, again, a robot that needs to go to the same edge of the pool every time so the customer can take it, I need it to go with in every kind of pool, not just the Intex and not just the, I don't know, ceramic pools. Okay. Okay, so our team mission in general, main robot lines algorithmic enhancement. So we are talking about the bread and butter of Metronics, about 1 million robots, I think, or close to 1 million robots in a year that are pretty simple with very low MCUs. We're talking about prices, let's say CPU of ARM M0, not something very expensive. We need to enhance its abilities using very low-level sensor, very affordable sensors and affordable CPUs. The second, and I will talk mainly about these kind of features that we do because of IP. So I want to talk a lot about the second line, that is smart robots line with extended navigation capabilities. Let's say like iRobot was in the start just hitting walls. So now we are going to a better solution to say, okay, I'm here in the pool, I was there, I want to finish there. And this is not very simple. I'm not saying regular robots is simple, but here it's a different problem. And technology infrastructure, like simulation and all kind of infrastructure that a company that deals with robots in 2023 needs. Okay, so we have just a couple of examples, not a couple, but maybe 4. Rattle for pickup. Okay, so can I activate the סרטון פה? בואו נראה. So this is a robot that came out about a half a year ago. כבר נראה. So what you see here is a truly wireless robot. And the problem with the truly wireless robots, okay, this is a robot pool cleaner. Drives in the pool and clean it. So the problem with the robot that doesn't have a line and just a battery is that you can't really pull it out when it's finished. So it just finishes and goes to a wall in the closest wall. And then you say, okay, I need to put it out. So I can take my hand or take I don't know, some stick or something. So the feature here was just to take a rattle and call it, okay? The feature was take the rattle. The feature was the ability to call the robot when it sleeps, okay? So the problem was communication with the robot in a low power mode and a cheap communication with the robot in a water environment. That means the water has lots of noises in it, so you need to do our solution was frequency separation, but frequency separation without, I don't know, A53 that runs a model that detects, inference of AI, right? But just a simple thing, you just took a frequency divider electronic-wise and just we created a watchdog that just listen to it and and then the CPU can rest in a low power mode and just and design the specific mechanical device that can trigger the robot and without triggering any false alarms. Again, another thing, non-touch temperature sensing. About temperature sensing, okay? So we have a robot and we don't want to add a hole into it just to allow temperature sensing because a nice gesture to the customer, but not that important. So the quality leader won't let you just put a hole. So because leakage and stuff, like we said, robustness. So what we did is built a machine to solve a lot of optimization equations with few dimensionals, and just to the machine output will be values that the MCU can just use them arithmetic wise, very simple in real time, and just guess what is the temperature inside the motor unit. Okay, so the first problem is that the motors and the currents in the PCB create a lot of noise, and also you are not in the water, you are in the air, and the water are there. So if you will wait to a stable temperature, it will take maybe 1 hour. So you also need to forecast what will be the temperature, the stable temperature in 40 minutes or 1 hour, and also need to overcome all the motors. So like I said, we use the very heavy solver to solve a lot of equations, and then just arithmetically simple MCU, you just take this and this and this value, multiply, and take the guess he has. Okay. In water application, also this cool and simple feature. We already had a pressure sensor in the robot, pressure sensor for filter indication. That's another cool thing that we did. So the pressure sensor take the barometric pressure when it feels that it is outside of the water. Maybe the robot just made an error and started outside of the water. Maybe we calibrated it intentionally through the app. And the thing is, also we did a watchdog that when the pressure rise dramatically, we know that the robot is in the water, and then you can activate it from far away. This pretty maybe more interesting stuff. So a robot with a camera inside of it. We wanted to know the cloudiness of the water, the NTU level, Achirut, get water cloudiness level. So you have lots of equipment that does it, very expensive equipment, and you don't want to add it to the robot because it's expensive and not robust. Maybe robust, but expensive. And we already had a camera, and there are methods that you take a target and put it like maybe 1 meter from the camera and say, okay, this is the target, you need to see it like that. And if you see it less clearly, so maybe the NTU is like that and like this. So this is an easy solution. But like we said, we want, one of the points are robustness and effortless. So we wanted to be effortless, so we just want the customer to throw the robot into whatever pool, see lots of features in the pool, like you see here. It's one example, and see in different distances from each feature, you want to see the differences in contrast. Okay, so if in 1 meter I see that is the contrast is let's say 5, and in 2 meters it's also 5.1. So maybe the pool is very clear. But if in 1 meter it's 5 and in 2 meters it's 7, the differences are very high. So the NTU is higher, and of course you can extract it into a extrapolation of exponent, and then see the results that are pretty good. Okay, in water slam, this is the most exciting thing we are working on, but we can't really talk about it. Okay, 2 minutes. So I succeeded. We can't really talk about it too much because of IP yet. So the feature is create a repeatable map and localization in the water. Of course, for the customer feature is to know where the robot was and just do the pull in 40 minutes instead of 2 hours. Also know where is the robot, when it finished the cycle, finish it in one spot. Okay, main problems are distance measurements, odometry. So you can say maybe LiDAR, but laser of 940 nanometers or this similar to it. The attenuation in the water is very high, so maybe you can see 10 centimeters, 20 centimeters, but not very far. You can say stereo vision, but stereo vision also maybe you will have a wall with the same color, with a uniform color, and it's a problem because you don't have the pixel to do the triangulation. Odometry, you have about 50% to 100% slide in the water, so it's also not very easy. And also dirt and stuff like that that you have also in regular robots that also not very easy, but this is another story. And also you have different levels, so about 2.5 dimensions, you can call it. It's not a 2D dimension, maybe like indoor robotics that needs to be 3D. So solution in short, you can't really, you can use imagination what we do. I'm sure you can understand, but in short, we created a very unique distance measurement for us. So it's like very simple, very cheap, say affordable, not cheap because it sounds cheap. So affordable measurement methods that we developed in our house, and unique sensor fusion, because like I said, it's not 2D that you can say, okay, I have a LiDAR and I have a 2D picture. It's a bit different. In the other hand, you don't have so many obstacles and moving parts like you have in a house. So this is the good part. That's about it. We have much more features. That's it. Now the questions. כמובן, כל דבר היית יכול לפתור אותו. כן, השאלה הייתה אם לא הייתי בקונסיומר, אם הייתי יכול לעשות את הפתרונות האלה יותר בקלות, נכון? משהו כזה. אז כמובן, אם הייתי עכשיו בתעשייה ביטחונית והייתי יכול לשים סנסור $10,000, הייתי פותר את זה, הרבה דברים הייתי פותר. כן, זה בעיקר האתגר, לייצר סביבה חדשה, אתה יודע שנגיד ניטו יצאו עם הלידר באיזה $30, אני חושב שניטו התחילו עם... אז זה היה סביבה חדשה, זה לא שהם המציאו לגמרי, זה היה סורקים, אבל עכשיו אתה פתאום עושה את זה $30 ואתה יכול לשים את זה בתוך רובוט. אז בגלל שאף אחד לא היה מאחורי הגב שלנו בדבר הזה, אנחנו צריכים לעשות את הצמיחה הזאת בעולם שהוא יחסית חדש. לא זאת אומרת, לא שאנחנו ממציאים מושגים מחדש לגמרי, אבל הניטו האלה לא היו לפנינו. זה הקושי. יאללה, כן. שמעתי שהיו כמה בריכות נוי וטיפול בבריכות שופכין. אני הבנתי שכן היו כמה פרויקטים שמטרוניקס השתמשו בהם בשביל בריכות מיוחדות יותר, אבל זה לא המס מרקט שלנו. כמו שהראיתי, יש לנו המון בריכות ספציפיות, ואנחנו צריכים לכוון את הפתרון, בטח אם הוא זול, למשהו ספציפי. אם הפתרון יותר אקזוטי, אז היינו משתמשים גם בחיישנים מפלצות, ותוך שבוע היינו נותנים איזה פתרון סביר למשהו אקזוטי.
מה באמת צריך כל כך הרבה דגמים, הכל זה רובוט שמנקה את הבריכה?
אז קודם כל תבוא לאיזה וויקלי אצלנו, מדברים הרבה פעמים על זה, זה דבר ראשון. דבר שני, תראה, קודם כל זה גם היסטורי, אבל גם יש בזה המון תודעת שיווק ואיזושהי הבנה של באמת 40 שנה, שיש לך כל מיני מפיצים, כל מיני, אתה יודע, מפיצים שהם יודעים שיש להם את ה-white label שלהם, שהם שמים את ה, לא יודע, ההוריקן בצרפת, והוא מרגיש מיוחד כי יש לו את הברנד שלו, כל מיני הסכמים שנחתמו. האמת היא שאני גם לא כזה מבין בתחום הזה של המרקטינג, אבל יכול להיות שזה באמת לא נכון, אבל כרגע זה מה שעובד, עובד די טוב. לא אגיד לך מעבר לזה. יש את פוסיידון שמטרוניקס קנתה לפני, לא יודע, 5 שנים, 8 שנים, שהם עושים מצלמות ממש, כי יש הרבה טריקים כאלה ששמים, כן, אבל זה באמת טריק שלא יעבוד מספיק טוב, נגיד יש לך רובוט עם מצלמה, אז מדברים על זה הרבה, אז יש לך NTU גבוה, אז מה תעשה? יש לך מפתח צר, מה תעשה? יש הרבה טריקים כאלה קטנים, שלדעתי הם לא מספיק רובסטיים, מטרוניקס קנתה את פוסיידון, שהיא עושה באמת לבריכות ציבוריות, ממש המון מצלמות, ובאמת עושים את זה ככה רובסטי וטוב, וזה פתרון שעולה הרבה כסף גם, אבל זה פתרון שבאמת עובד ומציל חיי אדם, ביוטיוב אתם יכולים לראות שיש ממש סרטונים שזה מציל. אז זהו.